Hello, everyone. Welcome to our developer coaching webinar. Thanks so much for joining us here today. My name is Tara Van Cleve, and I'm part of the technical marketing organization here at Oracle. And today we're excited to explore the powerful new features of Oracle Database 23 AI that bring AI and advanced search together. I'd also like to note that we are recording the webinar and you will receive the replay via the same email that you registered with after the event concludes. If you have any questions, we have enabled the Q&A section of the Zoom, and we'll be answering throughout the hour as well as leave some time at the end for any remaining open questions. So today, our webinar will be presented by Derek Cameron, Master Principal Cloud Architect. So without further ado, Derek, take it away.
So today I'm going to showcase a pure autonomous database solution that can be installed with a single SQL script that combines and focuses on many of the new search features in Database 23 AI. New in 23 AI is Ubiquitous Search, natural language to SQL, that came out actually in 19C. Vector search, new in 23 AI. Document search and hybrid search, also new in 23 AI. Now, this is not a deep dive into the database features. It's a brief review of the ways the database can use AI to search and analyze data using natural language to SQL, vector search, ubiquitous search, hybrid search, document search, and image search using our new multimodal image models and kind of how these all work together. For more information on some of those features, Steve and I have done previous presentations in February 2024. We introduced Select AI. We covered vector search in August 2024. And in January this year, we kind of went back and did a complete full cycle review of the AI services out there. Select AI, vector search with RAG and generative AI agents. I'm not going to be going into a lot of detail on those, but we are introducing a couple of the new features, hybrid search and ubiquitous search, and we've also integrated image search into a demo application. Prior to 23 AI, if you're a veteran like me, going back to version 7, all the search techniques leading up to 23 AI were really focused on text matching. You could do character, words, fuzzy pattern matching, sounds like, on specific tables and columns, but every table and columns needs its own index. And in version 23 AI, the column limit has gone up to 4,096 from 1,000. And believe it or not, we do have customers who are chaining tables together because they have more than 1,000 columns. So every search needs to be directed to specific tables and columns. It's really not practical to search your entire database till now in version 23 AI. Ubiquitous search enables you to perform full text and range-based queries across multiple objects within an entire schema. There's a new package. It's called DBMS Search. It's a PL SQL package. You use that package to create, manage, and query those indexes. DBMS Search index on tables and views over schemas as long as you have select privileges. You can add data sources. You can also remove data sources that are tables, views, even JSON duality views it supports. And all of the columns in the specified sources are indexed and available for full text or range-based search. Select AI, as I said, we've covered this in the past, so I'm going to breeze through a couple of the slides here. Just know that the Select AI allows you to build applications that allow users to interact with their data without knowing SQL. We've done many Code Innovates events using Select AI. It's been incredibly successful. All of them have been very successful at answering the questions the customer wanted answered using Select AI. Supports things like Run SQL, Show SQL, Explain SQL, narrate, and chat. There's just an example on this page here. Supports different language models as well. Most of our customers want to be purely within OCI, and we have our Llama models that do a great job of, excuse me, generating SQL. This is just an example of how that works. There's a prompt. The table is augmented with instruction information. It's sent to the language model. The language model generates the SQL, and then when the SQL comes back, it's executed. And it does rely on profiles. In this demonstration I'm going to be showing you today, I have multiple profiles for different subject areas. You provide the credential name, the model, and the objects that you want to pose questions to. So AI vector search. Vector search new in 23 AI. I'm sure many of you are somewhat familiar with it. We'll be doing some of that today, but we'll be integrating it with other search techniques so that you can do a much better at answering the questions you pose. And it really, you vectorize the user question, you take and you compare that with the embedded vectors that you've been generated that are on your text. You return a number takes that vector search, returns text chunks. The text chunks are sent to the language model for interpretation. The language model reads that and comes back with a synthesized answer based on those text chunks. Now, document search isn't vector search. What I ran into is the fact that if I want to get a summary of a document, say the Constitution, that document is more than 32K. In fact, all the documents that I have that I've been testing, that I have in my demonstration, are all over 32K. And when you want a synthesis of that document, if you use vector search, yes, it'll work. It'll find relevant chunks to answer the question. But if you've got a 200 or 300 page document, all it's doing is coming back with 5, 6, 8 text chunks to answer the question, and sure, it can summarize that. But if you want a more comprehensive analysis of the document, better to send the whole document to the language model. So separately, we have document search. Hybrid search, new in 23 AI. And this is, I'm not going to cover this in any kind of detail. It's actually a fairly big topic because it offers a lot of different techniques for combining keyword search with vector search. It allows you to, in a single package, it allows you to build concurrently a vector search, embed the vectors of your data, and also allows you to index the text chunks that are in it and then come up with various strategies to combine those two searches and return an answer. And this is just a diagram of how it works. You can see if the statement there, create hybrid vector index. You can see it on certain documents. It's got some parameters. And you can see in the middle there, we've taken a Word document, a PDF document, some text and HTML. And on the right, it vectorizes the text. It creates the text chunks off those documents. It vectorizes them and maintains a vector index. And then on the left, it also builds a text index on that so you can combine those two search techniques. Let's just briefly show you how that works. And I'm not going to go into this again in very much detail. It gives you different strategies: pure, semantic, and document mode. Pure semantic. Now, semantic is vector search, right? Pure keyword and in document mode, that is Oracle text at work. And then you've got keyword and semantic in document mode. I've elected to use that strategy. And then you've got keyword in semantic in chunk mode. So you can go down through this document and decide and do some testing, decide what search methodology is most effective. You have in your search, you can actually specify it. And I've got this embedded in my Apex application, the search mode, the number of chunks returned, etc. And you can go through this and look at your strategies. So today I'm going to switch things up a little from what we've done in the past. I used to build it up. I used to show you how things were built and show you the end result. I'm going to flip things around and show you an Apex app. I'll show you an Apex application. And in this application, Steve has created a workshop, all of the database objects, everything that you need to have this thing work in your autonomous database environment. You only need an autonomous database and access to AI services, and you can install this depending on, well, the whole thing will run, the whole install will run in less than an hour, except for the hybrid search. It takes a while to build, but very easy SQL script to install everything that you're going to see today on your own environment. So let's get started with the application itself. View PDF documents. I've got a view file here. You'll notice I've got add documents. So this is just presenting the documents that I've added. I've got a document viewer here. So if I want to look at the document, say I want to look at the Constitution, there it is there. I've got an embedded viewer inside Apex. And you've also got AI search. And if I look at AI search, I ran this prior to this, us starting today. This takes 30, 40 seconds. I thought I'll just pose that initially up front. It's document to search, it's the Constitution. And I asked the language model, summarize this document. If you'd have done this in vector search, you'd have gotten 1 or 2 sentences. So it's done a great job of reading this 85-page document, synthesizing it, and showing you all the information about it. Now, this application is using a running conversational interface. So whether you do a search on a PDF document, an image document, whether you do search, vector search, natural language SQL, hybrid search, all of that is constantly tracked in this running conversational interface. You want to clear the conversation, you can just say create new conversation. I also maintain domains. I'm using a default domain, and we'll get into that in a minute. I'm using document search, and there's my question and my answer. I'm tracking conversations down here. Every conversation is running independent of any other, so you can have concurrent users having their own private conversations, and a running tracking of all the questions. We call them prompts throughout. So I will close this. And I'll just go to image documents. And image documents allow you to upload images and then to pose questions to the image. It's not using document understanding. It's not using that. It's using a multimodal image language model. And it can answer text questions. It can analyze documents. I took a picture of my California lilac yesterday, uploaded and said, that's a California lilac, blah, 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 blah. It knew it all about it. But it was amazing at extracting text out of this. I've got a squash document. I play squash. I actually played in this squash tournament, but I was not in the men's open or men's 40 plus. But I'm going to give a question to this document, and I'm going to ask it a question. I've still got in context, I've still got my other question. I'm going to say, these are the winners of the Canadian Squash Championships. Who won in 2008? And it's going to go through this, and it understands the rows and columns according to the image. Winners, blah, 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 Adrian Griffin and Josh McDonald. And in 2008, yes, it was Adrian and Josh that won the tournament. I'm going to close that. I'm going to go to a more complex image. This one here, I have a Culligan water softener. So I literally just took my manual. I thought I'm going to ask some questions. And we've struggled in the past without image analysis of reading these tables, these table formats. You can see this one's fairly complex. And extracting the text from this and finding data in it can be really challenging. And what I'm going to do is I'm going to ask a question out of this that's going to force the language model to, or the image model to read this, translate the text, and tell me the answer to it. What is the efficiency rated dosage for a 14-inch model? There it is there. It tells you it is 4.310, 4,310. Where is that? It is over here. There's the flow rate. You can't see it here. Anyway, it has correctly pulled out the values from this table, so I'm very, very impressed with the efficiency of that. And we'll ask one more question. What are the different modes of operation here? Again, to be clear, this is not a PDF. This is a photo, right? It's a photograph. And it's going to go through this. It's going to find the blocks of text. And here it is, water meter mode, aqua sensor mode, et cetera, et cetera. So yeah, it's really amazing. And in this one single app, you can analyze images, analyze text documents, and the document support. Take a look at the documentation. 150 different formats are supported. You see Word, PDF, PowerPoint, even zip files. So yeah, it's really, really amazing. So let's go to add documents. I support adding documents. It maintains the global search. It maintains the hybrid index. It maintains and generates the vectors. So when I create a document here, I give it a file name, a file type. Is it an image? Is it a document? What kind of document is it? I choose the file, and optionally, I can create domains. So think if you've got AP, accounts payable, accounts receivable, AR, financials, or other businesses, oil and gas. I'm working on a code innovate with oil and gas this week. So you can create different domains, and that allows you to direct your search in different areas. And when you enter all this, it has a trigger on this table. The trigger creates text clobs, extracts all the characters out of that table, and it sends a job to the scheduler, executes that in the background so you don't have to wait. Even if it's a large document, it runs offline. Vector, it creates the text chunks, the vectors, stores those in the table, and then makes it available for search later. So I'm going to close that. Let's go into global search now. Now let's take a look at the global search indexing, which again, I found is pretty amazing. I'm going to search for the word law, and I've indexed a school database, a movie database, and a document database. These are all completely separate tables. They could be in different schemas. And what I've done is I've used Apex to highlight the word that it's found, and it's searched across all the columns. You'll see it there. Even if those columns have JSON data, it'll find it in the JSON. And if you go down to movies, again, you'll find it throughout the various columns in that. And this, I've shown it in the text chunks, but it could be in a character large objects, any text medium, it'll find it and display it. I show also the index has a score. The score is scoring based on the incidence of the word found in the image, in the document, compared with where else it's found in the database. If you have a very commonly found word that's in all the documents, the score goes down. If it's frequently found in the current document, but not found anywhere else, it provides a higher score. You'll see the scores are different here. So there's a whole scoring algorithm that comes with search. Now let's move on to search documents. This is a combination of natural language to SQL and vector search. So I have created a domains table. The domains table has the AI service that I want to use to search that database. And it also, if it's natural language to SQL, has the appropriate profile. So if I go to movies, and let me find my movie question. What are the top 10 movies streamed in the United States? And so now we're going to use a language model to take the profile, the descriptions of all the movies tables and views, generate a SQL query, and execute that query to answer the question. And Obviously, if I have different subject areas, here it is here. I've conditionally displayed the backup information that was used, the query that was used on the right-hand side here. It's generated this query. We've executed it. And I've used the narrate function to explain and present the results. The top 10 movies streamed in the States are, you see them there. And you can see again, we're having a conversational thread here that is maintained. I've got a select AI query. I've got an image search query, a couple of them. I've got document search, etc. And again, I can always clear this. Let's ask another question. And I'm going to ask this of, this is now a vector search. We're going to do a vector search of documents in that database. And let's pose the question. And now I'm going to ask a question of a database of documents. It's got all the Texas, well, all of the Texas House bills, 20 Texas House bills. They're fairly lengthy. It's going to go through all of them. It's going to do a vector search. It's got a question here. I have decided to leave the spelling error in my question. Amazingly, it knows my jumbled word there. It's figured it out that I really mean infrastructure, figured that out, and then it went through, did a vector search, found there's the answer, answers the question. I also give you the underlying documentation that was used to answer that question based on the vector search results. I have the documents listed in order of relevance here. I use a re-rank function to retrieve that. So I get the chunks back on vector search. I send them to a re-rank and say, well, out of these 5 chunks, which ones are most effective at answering this question? It rates them. You can see the rating there. It's got House Bill 9, the different chunks that tell you how that information was extracted, the answer that is. And I've got even citations, the individual code snippets within the text chunks themselves. So I'm going to ask one more question because I'm setting myself up for a follow-up question. And that is, what legal documents address public safety? So the documents that address public safety, there's a number of them that are in the database, and remember, it's bringing back the top 5 chunks, and it's taken those 5 chunks and it's answered the question. You can see the references there. It's found House Bill 9, et cetera, et cetera. But those are not all the chunks, all the ones that address public safety. There's other documents that address public safety. It's found the ones most relevant. So what do I do about that? Well, if I go into vector search with keyword, I can then say, well, hang on a sec. I need to focus more, I need to have other filters on top of this. And so the keyword I'm going to put in here is invasion. And I know that only one document has the word invasion. And so now, same question, also vector search, but now pre-sorting based on this keyword. And so vector search with keyword, the keyword's invasion. The Constitution is the only document that has the word invasion. So then it's filtered within that. It's done a vector search within that key document, and then it's pulled out the chunks to answer the question. Let's go to hybrid search now. And the search term here, I'm going to again pose that same question. And you can pose multiple keywords here, but I'll use the word invasion again. And I've only done the search. I could have taken the results. I could have sent the text to language model, asked for the answer back. I could have done that. I've just elected at this point to show you the pure search functionality here. Now remember, there's a vector search and a text search happening concurrently at the same time, looking at an index, looking at the vectors, and it's come back with a score. It's come back with a vector similarity score here. You can see that there's other documents that have similar content here. House Bill 3 361, 371, Constitution. However, those other documents do not have the keywords that I was looking for in them. And so you do see that there's a text score here. I could have, of course, insisted text score is above some given threshold. I could have done that. So you can see you can modify and fine tune your search techniques to ensure you pull back what it is that you want. Now, the only other one that I'll touch on is search document. Again, we've already done this when I was viewing the PDF documents. I'm not going to reissue it, but you can do a separately a search document in here. Now let's look at some of the underlying components of the demo. We have domains. You can add your own domain. I've got 3 in here. A default, which is my AI service called, is vector search. I have a movies and I have schools domain saying select AI. The significance of this column here is that it is a PL SQL function that pulls back the data. And so when you ask about a document that's got a default domain, it knows to do a vector search. When you have a question about movies, it knows to do a select AI. And I could have actually done vector search on movies as well, added that in here, but it's just to show you that this is driving the direction of where those queries are sent. I have 2 AI profiles here for select AI. I use the appropriate profile for the different domain. And of course, I've exposed the AI configuration. You can see the settings here. You change the settings. Of course, it drives the settings on the functions that are doing the language model queries. Prompt instructions. I have a preamble. I've played with this. I've added additional language model prompts in here, rules that you can add. This gets prepended to your question, prepended to your request that goes to the language model. So you can add multiple here, you make it active, and then it's basically prompt engineering. So we support the prompt engineering. I've got a basic one here in my other demo. I've got others that I could use, but you want to add your own prompt engineering, you just add a row in here, make it active, and it'll immediately be put into the pipeline for your searches. And of course, we have search history, all the searches that I've done here. I've got search conversations. You want to just focus on image search, or you want to focus on select AI. You see you've got the show SQL here, vector search. You can see the references and chunks here. So you can go through and crawl through your conversational history to see how effective it's been at answering end user questions. So with that, I'm going to switch gears a little, and I'm going to go to some of the underlying components that make up this demo. That's the Apex demo. It'll be available for download and install in the workshop that Steve's put together, and we'll be communicating that. Let's go to SQL Developer, and let's look at some of the underlying pieces that support all this. And the important thing to emphasize here is you could say, Derek, we don't use Apex, it's great, but we use Node.js, or we want to use some other third-party application development. All of the questions that I've been posing here are just executing SQL. And I'm going to show you that after I look at the underlying tables. We'll just do some of those queries right in SQL. So you can plug this in to any application you want. It's using under the covers pure database communicating with language models. So documents, you add a new document, it's going to insert the row in here, it's going to create the CLOB in the background, extracting the text, and it's going to kick off a job to vectorize the questions, to vectorize the text. Here's the vector chunks here, document ID, the chunk ID, chunk size, the text chunks themselves, and the vectors themselves. We track all the conversations in a conversations table. There's the conversation ID there. And the prompts and the responses, when it was asked, the chat history for conversational context, the citations, the documents, the domains and the AI service that was used, and all of that's maintained here. We also have flattened the JSON because everything, requests, responses, everything's JSON. Of course, database is fantastic at managing and handling JSON. So I can flatten this into rows. This is actually, if you look at the SQL in it, it's really just a JSON table query. And I've flattened that. So that's what you're looking at in Apex, but of course, you can just do SQL queries on it as well. And the other objects that we're using to support this, there's the views. You can see the tables. This schema here literally was created by running a SQL script. It's just a SQL script. And so we've all of the data, including the data, the objects, the packages, procedures, functions, including the data is all installed in the SQL script. So you'll be able to plug this into your environment. Let's go down and take a look at some of the other objects that are used to support this. We've got a package. The package does things like adding conversations. Let's open this up a bit. Adding conversations, adding prompts, adding and creating the document vectors here. And I've got some utilities rebuilding the vectors. If I want to rebuild vectors, I've got them there. And yeah, probably the biggest, the place where all the logic and most of the logic is being done are on these functions. And if you look at them, I've got a wrapper function for AI search. I query the AI service in the domains, and if the AI service is vector search, I execute this package here, this document, this function here. And if it's natural language to SQL, I issue that one. And then let's take a look at those. I'll go into the documents here. And I'm not going to go through all of this in detail. We did that in the past presentation. I will touch on a few things here. There's a lot going on in here. The AI search calls this function. I retrieve the conversation ID and the prompt ID. I retrieve the configuration. I retrieve the previous question and answer to prepend to the current question. This is for vector search context. I vectorize the user question. I retrieve the chunks based on vector distance. Right there, you can see vector distance function. I add the prompt instructions. There's the prompt engineering. And I do some formatting, and then I rank the chunks. I send them to a re-rank function, a language model for ranking. Then finally, I plug this thing in. I have my documents here, and I have my questions here, and I provide the chat history for context, and then I store the result. Everything gets stored back in tables for either analysis later or for providing context on future questions. I'm not going to go through all of these. I will touch on this other one here. And this one here is slightly different. If you're doing vector search using JSON functions, you're going to hit the 32 kilobyte character limit immediately. And so you need to formulate the request a little bit differently. I need to manually build it. Again, it's all maintaining your document, your context, your conversational history, but I now need to manually build the request components and then use dbMSLOB append to stitch the different components together so that I can issue theoretically a request up to a club, which is 4 gigabytes. Now, you'll never do that, but the point being is that this allows you to do questions against documents that might be a few hundred pages or even more than 50 pages. It's going to be blowing up the 32K limit. So let's go back into SQL. I told you I would show you how the queries are actually executed. This is stuff that's in Apex. There I am there. There's what movie Tom Hanks in. There it is there. There's the answer. Now I'm using my wrapper function, but it's really doing the same thing. I'm going to issue that. I'm using AI search. It looks and goes, oh, movies is select AI. It's going to run the natural language to SQL query, and it's going to come back. Ultimately, it's issuing that code just above here. There it is there. And if I'm doing vector search, there it is there. It's going to be doing a slightly different one. It's going to execute, the AI search is going to send it to this chat documents function, going to do a vector search. And there it is there. You've seen the answer in the Apex application there. And if we do document search, remember, uses a version, and you can see there the document search. The document search is a modified version of the documents, and there's the document search there. Canadian gives me the answer there. It uses an image model, a language model. It's a slightly different function. And I'm not going to issue this one here. You've seen it again in the UI. Takes a few seconds. Let's get on to kind of the net new ones, which is DBMS search. And there it is there. You can see that it's looking at a global index where it contains data invasion, and my data source, I'm directing it to documents. So that is the SQL statement that is getting issued in Apex. You can see it's indexed, so it's pops. It's very, very fast. And in Apex, of course, I'm substituting the source and the keyword in here, but here's how you can build that into your application using a contains clause that does a text search against your database. Now let's look at the hybrid search. And the reason the hybrid search is a little bit more lengthy is you have to tell it what strategy do you want to use, there's different settings in here. What is your rank penalty? The search fusion is a union. So you go through the documentation. You can use an intersect. You can use different strategies. But this is the code. This is the code that I'm executing in Apex to do a hybrid search, searching both the vector index, searching the text index, looking at the score in both of them, and then coming back with the results and presenting that and allowing you to do with that whatever it is that you want to do. This is just going to return, again, the values that you saw in the Apex app. There it is there, the vector score, the text score, but this is the SQL statement that is executed to do that. There's another table I want to touch on. I overlooked the global index. When you create a global index, it creates a table of the same name. And for every source document, it adds a row for the primary keys so that it can use that primary key to do the index search. So if you have 10 tables, every table has 1,000,000 rows. You're going to have 10 million rows in this. Might seem like a lot, but it's only storing the primary key. It's not storing the data. The data continue to be maintained in those indexes. And when the indexes are built, there is a default job that runs to maintain those indexes. I'm going to remove the filters here. I'm going to clear the filters and show you the underlying tables. You don't need to concern yourself with these. I've gone and kind of poured through them. There is some interesting information in the hybrid and the global index tables here. These are tables that contain information to maintain those indexes. They get created automatically. Don't touch them. They get deleted when you drop the index. So yeah, there's lots of tables that get created, but this is no different than machine learning. If you create a machine learning model, and I've got ones that have got hundreds of tables because I've created many, many models. These dollar tables are used to maintain those models and indexes, and you just be aware they're there, and you might even query them sometime for some of the information that they store. A couple of other things I want to show. All of these functions, because an Oracle database supports REST data services, I have exposed these documents as REST endpoints. So think about it. You have all of this logic, the maintenance of conversations, the storing of those. You back the database up, everything gets backed up. You back up, you do an active data guard, you replicate this to another region. All of that data, everything gets maintained separately. You want to restore from the database. All of this infrastructure is encapsulated in that database. But if you say to me, I want to use Oracle Digital Assistant to do I want to use these functions, I can just go in, I can expose it as a REST endpoint. I'll go here, paste. I'm now doing a search using that same function you've seen me execute in SQL. You saw me execute it in Apex. And now I'm executing it in a browser using a REST API. And there it is there. There's the answer. So yeah, now your database can be a hub for deploying AI applications and having all of that backed up and maintained without having all the bits and pieces that we see so often with AI applications where you've got code running here, code running there, Python, SQL, of course, and many other technologies working together. This is 100% database, very simple, backed up. Now you might say, well, this looks really interesting. I'd like to implement this in my database. So Steve's put together this workshop and it covers everything. It covers ensuring you have access to the AI service, creating the database user right from scratch. I'm creating a search 23 AI database user, updating ACLs, the access control list, setting up the movie stream data so it installs it. You don't need to import it or install it yourself. This automatically does that for you. You need credentials. Of course, you need credentials. That's kind of a critical step. If anything fails, it's going to be this if people don't properly create these. And then the database objects, the tables, the AI profiles. We use an Onyx model for hybrid search right now. If you have a dedicated cluster, you can use those, but for on-demand models right now, we're using an Onyx model. I give you the Onyx model. It'll be part of the install package. You load the data into the database, load documents into the database from object storage. And you got the zip file there, sample PDFs. You don't need to load these. They give you the demo, but everything else you could just start uploading right through your Apex UI. And there's the setup. There's the index creation. Really simple. You just need to create the index and start adding a source or removing sources. Super easy. The hybrid search index, a little bit different, but you create a preference. You create a preference object here and then reference a preference object when you create the hybrid index. Note, for the data we have in here, it takes 75 to 90 minutes for this index to build. It is time consuming. Once it's there, it's fine. And then there's optional. This is all just informational. This isn't part of the build of this demo. And it's just showing you breaking down some of the code blocks to tell you what's going on. And then we've got some sample queries. And I've already executed some of this. So at this point, we're done with the demonstration. I hope this has been helpful. Open your eyes to how easy it is to build AI search applications. You're going to probably need an Oracle database anyway. Use the AI features in the database. They're all part and parcel of it. You connect to your language models and you're off and running. So with that, I'm going to stop sharing and Steve can talk about the Code Innovate, where we're applying a lot of these techniques to customer use cases. Okay, Steve.
Great, thank you, Derek. Um, there were quite a few questions in the Q&A related to past webinars that Derek and I have presented on vector search, select AI, and in general. Uh, as some of you may know, the Code Innovate program delivers a lot of these webinars. So I just wanted to point out real quick that if you go to YouTube and do a search on uh, Code Innovate, we have an entire playlist of all of our past recordings. So Derek referenced Gen AI in a database that we did 4 months ago. There that is. If you scroll down or you do the search, there's the vector search with Gen AI that we did 9 months ago, um, and so on. You can search and find not only the ones Derek and I did, but we have a greater team of great engineers that deliver content almost on a monthly basis. So I just want to call out this Code Innovate YouTube playlist for all of our past recordings. And this one will show up too eventually once it's packaged. But now I want to talk about the Code Innovate program. What is a Code Innovate? A Code Innovate is essentially the experiences customers have use cases. You have a use case that you want to work on. We ask you to bring your use cases. We work on your use cases. We don't have canned demos or canned use cases on a menu that you pick from. We ask you, what do you specifically want to work on? What do you want to explore in the Oracle Cloud? And then we start there. We found that this approach, working with customers and Oracle engineers together, rapidly allows you to share knowledge between Oracle and you all. And at the end of the time, and you'll see what a Code Innovate looks like in a moment, you'll have a first pass prototype or a minimum viable product working that is on your use case. So from a logistics standpoint, what is a Code Innovate or virtual Code Innovate? It's a hands-on introduction to the cloud services. It takes place in a singular week, Monday through Friday, 4 hours a day. You choose the week that you want to do it, and you choose the time frame for the day. So you do 9 to 1, noon to 4, whatever. But it takes place in a singular week, Monday through Friday, and it's 4 hours a day. Our engineers work online, live with your team to build out your use case. And I keep saying use case and your use case because that's the key. We leverage your use cases, your interests, what you want to work on. And it's at no cost to you if the minimum requirements are met. And you may ask, well, what are those minimum requirements? We ask for 4 developers or more. So Code Innovate can consist of one team up to many teams. The commitment is 5 days, 4 hours a day for a total of 20 hours during the event week. We also, one of the requirements is you bring your use cases. And then the lead time, depending on the services and availability, can stretch anywhere from 3 weeks to 5 weeks. And so those are the minimum requirements for Code Innovate. And so this is what the timeline looks like. So you have use cases. You reach out to your Oracle Cloud sales rep and say, "Hey, I'm interested in the Code Innovate program." We meet with you, determine the use cases, and then we ask you to pick a date. And so once the event date is confirmed, which is typically 3 to 5 weeks out in advance, we then work throughout that lead time to do things like pre-event setup. And pre-event virtual setup is essentially ensuring that all the services are spun up, available, and all the participants are going to have access to those services. We also do what's called structured learnings. The structured learnings are really key if you're new to a service or new to features in an existing service that you use. The key there is we want to make sure that you've seen and had some experience with the Oracle Cloud services that you're going to work with prior to the event week. We don't want it to be net new first time you're seeing it the day of day one. And then the last block just represents the actual event itself that takes place in that 1 week time frame. So at this point, that's it. That's what a Code Innovate is. You'll see up in the right-hand corner our email address that you can email us directly and inquire about the Code Innovate program.
All right. So thank you again so much for joining us here today. This is an ongoing series, so we do have more upcoming events on the calendar, and you can find all of those at oracle.com/developers/events. Thank you again so much for spending your time here with us today, and we hope to see you at the next one. Thank you.